Hey guys, welcome back to my channel. So today we are going to discuss another problem, but before going forward, if you've not liked the video, please like it, subscribe to my channel and hit the bell icon so that you get notified whenever I post a new video. So without any further ado, let's get started. Problem is find duplicate subtrees. So in this problem we are given root of a binary tree. So these days these like tree problems are coming. So yesterday problem was also kind of a tree problem. So today's problem also is tree problem. So we are given root of binary tree and we need to return all the duplicate subtrees. Easy, right? So for each kind of a subtree, you need to return the root. So if you see this is same subtree as this one, so we'll have to just return the uh, only need to return the root node of any one of them. Okay, so we don't have to return both. We just need to return the root node of any one of these. Okay. So trees are duplicate if they have same structure with same node values. So if you see here, this is one subtree and this is another subtree. Both these subtrees are same. So let's understand the problem once. If you have understood the problem, you can directly go to the approach. So see, in this tree, right? If you see this tree, this subtree and this subtree, they are same, right? When you say they are same, it means they are duplicate of each other. Duplicate means they have same values and they have same structure. Same structure. So structure should also be same. It cannot be like this, that 2's left, instead of left, right child is 4. Then these two trees are not same. Okay. So another, so one is this tree, this subtree 2 4. This is one duplicate tree and other duplicate subtree is this one 4 4. So if you see 4 4, these are same, right? Hence 4 4, this is also one subtree which is duplicate, right? So this is the answer. Okay, so I hope you understood the problem. Now let's see how we can approach it. Okay, one basic approach which directly comes into mind is one that we will be storing the tree subtree which we get till now, and once we again get that same subtree, we will know that okay, they are duplicate, and hence we will store that root of that subtree. So that approach is fine, completely fine. So basically what we do in that approach is, so let me quickly draw the tree again. So the tree is 1 2 4 3 2 4 and 4. Okay, so see, basically what we will do is we will take a hash map, right? We will take a map, unordered map, dictionary, whatever you want to say it. So we will be taking a map which will store the subtree and the count of the subtree. Okay, so you might be thinking how we will be storing the subtree, like how we can store a subtree. So we will be storing the subtree in a form of a string, that is whatever the subtree is. Let's say the subtree is A, B, C, right? So we will be converting this subtree into a string, that is we will be doing serializing. We will be doing serialization. Serialization means converting a tree into a string. So basically we can use any order traversals: in order, pre-order, post order. So I will be picking a post order. Why post order? Because post order has left, right and root. So we, in post order, we have the left result first and right result first, and then we have root. So this approach looks good to me. So I will be taking post order. So here, if you want to serialize this tree, it will become something like the left child converted into a string plus the right child converted into a string plus the root node. So the string, final string would be after, like, so basically this subtree when serialized will become BCA. BCA. Obviously we will be, since these will be numbers, right? So it could be 13 here or 4 here. So we'll have to separate these numbers. So we'll be separating them with a comma. Why to separate? Because We don't want this 13 to be taken as 1 and 3. We want this 13 to be taken as 13, right? So comma 4, this would be good. Otherwise, if you do not give comma, right, see what will happen if you do not give comma. Let's say this is one tree, 13 1 4, and let's say this is one tree, 11 3 and 4. Okay. Or let's have it like this: 1 4 and 13, and here it's 4 and 3. Okay, so if you see here, if you convert this tree, right, into if you serialize this subtree, you will get left, right, and root, right? So left is 1, then right, so this will be a string, right? This will be a string. So left, then right, and then root. Similarly, if you serialize this subtree, it will be left, then root, right, and then root. So see, these both trees gives the same serialized output. But obviously these two trees are not same, right? So in order to distinguish between these trees, we'll have to separate it with the comma. So our string will be like this: 11, 3 and 4. So basically the left string, whatever left string is, then comma, then right string, right subtree string, whatever it is, then comma again, and then we have the root. So basically we will be separating by comma. Okay, so this is how we can uh, approach it. Like, let's quickly do the dry run once. I hope you understood the approach. Let's see how we can use this approach. All right, so see, what we will do is we will be taking a hash map, right? A map we will be taking. We'll be starting from the root. We will traverse in a post order format, post order. Okay, and what happens in post order is we go to left, then we go to right, and then we go to root. Okay, so we'll be going to left. We are here at root, we go to the left, then we again go to the left because it's post order, so we come here. So for this 4, if we have to get the serialized string, what we will get? It will be 4, that is the root, plus the left, which is, let's say if its child is null, so let's say we will be returning dollar, let's say. So dollar, so sorry, my bad. So first of all, what will happen? We'll have the left, right? So left is nothing, so it's dollar will be returned. Then right, again it's nothing, dollar will be returned, and root will be 4. So this will be the serialized string. So this serialized string we will store in the hash map, that okay, dollar 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 4 has count 1. Okay, and then we have finished this one, so we will return the string, whatever string we get, right? Serialized string will return from the call. So for this 2 now, left, what we got from left we got this dollar dollar 4. Then from the right, for this 2's right, nothing is there, so dollar will be returned, right? So if root is null, base case is if root is null, just return dollar. Okay, so dollar will be returned as right, so we will be separating, guys, don't forget, we will be separating with a comma, then root. So root is 2. So this is the serialized string which we get when 2 is the root node of this subtree. So we'll store this also in the hash map. So dollar dollar 4 comma dollar comma 2 has count 1. Okay, now let's say for this one also we will be getting the string and all. Now see, let's say for this 4, 4, right? So for this 4 again, what you will see? You will see that okay, for this 4 we get the serialized string as dollar dollar 4, and this dollar dollar 4 is already in our hash map, right? So it means that this is a duplicate subtree. So we will store the root, whatever root is of this, because we have to return what? We have to just return the root node, right? So we will be storing 4 root node since it's a duplicate, right? Okay. Now what we will do? We will go here to this 2. So now if you see for this 2, what is there? For this 2 left, we get this thing, comma, right we get null, dollar, and 2 as this. So again, if you see, this thing is already present in the hash map. So this is also a duplicate subtree and the root is 2, so we'll store 2. So these 2 will be the duplicate subtrees. So this is how we'll be finding duplicate subtrees. I hope you understood the dry run. Let's quickly see the code. So if you see the code, it's very simple. If root is null, we are just returning hash. You can return dollar, anything you want. Okay. Then we are doing left call. We are doing the right call. So basically, this is simple post order traversal. Then we are making the string, serialized string. So this string which we make, right? This string we are making here as left first, then comma, then right, comma, and the root node. Okay. If in the map, so subtrees, this is a map. If the map already has this string count as 1, right? Like here count was already 1, or here count was already 1. So it means we have already got this string, this subtree earlier. So just in the duplicates, add this root node and increment the count. Okay. After that, we'll increment the count also here. All right. So I hope you understood the problem, right? So this is address will be returning the, like here we'll be returning the string whichever we have created here, and here we are passing by reference. So if you see, we are returning the duplicates which is containing all the root nodes of the duplicate subtrees. So I hope you understood this approach and the diagram. What will be the time complexity? See, the time complexity for this will be O of n square. Why O of n square? Because see, one thing is we are traversing on each node, right? We are traversing on each node, right? And then we are making a string. So let's say for one node, there are in the serialized string, right? Let's say there are n nodes for a subtree. Okay, n nodes. So basically for a subtree, let's say there are n nodes in its serialized string. So in the worst case, there could be n nodes having n length string, right? Serialized string. So it will take n into n square time for all the computations. That is, there is, let's say for one subtree, we are making serialized string, right? Which has length n, one subtree node, right? Like one subtree root node. If there are n nodes in its serialized string, then for n nodes, how much will be n into n, right? This is the time complexity, and space is also same because we have to be anyway, storing these strings in the hash map, right? So it will be n square. Now we can do better than this, right? We can do better than this. Let's see how. So we can do better than this approach. Let's see the optimized approach. So optimized approach is 1, 2, 3, 4, 3, 2, 4, and 4. Okay. Now earlier guys, if you see, we were, we are creating this, we are just having this 2 string, right? We are converting into string, right? Instead of that, what we can do is, in order to avoid this extra computation of O of n, we can return somewhat called as id, right? A number. Earlier what we were doing, a subtree was identified by a string, right? Now a subtree will be identified by id, like this integer, one integer. Okay, it will be identified by an integer. Let's see how. Again, the process will be same, that we, let's say if the subtree here, what we were doing here above, we were making a string of the subtree. We were like, basically this string was representing the subtree, and this string we were storing as a key, and the count was the value, right? Same thing we will do here, but just instead of a string, we will be having an integer which will identify the subtree. So the main concept of this approach is that integer will be representing the subtree. Okay, so we will have a hash map in which the key will be the integer, or you can say the ID, and the value will be the count of how many times that uh, subtree we have got, right? Okay, so let's say if base case will be, let's say base case is that if root is null, we just return 0 ID. So earlier we were returning some special character, right, as a string. Now we'll be just simply returning an integer, because a subtree is now identified by an integer, a tree. So if it's a null tree, like nothing is there in the tree, its ID will be 0. So this is your ID, okay, this is your ID. So let's see for this one, for 4. Its left child, we will again do post order traversal, right? We'll be doing post order traversal only. So first left, then right, then root. So here from the left we get, since its roots in null, left child is null, so we'll be getting 0 as ID. From right also we'll get 0 ID. We'll convert this 0 again, comma 0, comma this 4. So this will become our new triplet. So basically this will be a triplet kind of, because we know that always there will be 3 values, right? One is the, so basically these are IDs, right? So these are IDs. If you see the code also, basically what we are doing is we get the ID from the left child, we get ID from the right, we get ID from the right, and we just append the current node value in it. So either you can do in order, post order, anything you want, you can do that. Okay, and then you will see that what is the count if this triplet is already present or not. Okay, so if you will be storing this triplet here 0 comma 0 comma 4, right? Basically this is a string, right? This is a string. So okay, you will be storing this. I'm just remove these brackets, don't get confused. This is basically a string only, there is no brackets. Okay, so you will be storing and you will check if the count is 0. Let's say if the count is 0, that means it's not present initially. So we will give it a random ID, right? We have to just give this triplet a random ID. So we will give this triplet an ID, let's say the total size of the map plus 1. So total size initially is what? 0 plus 1, 1. So this triplet will get ID as 1. Okay. Alright. Now for this 2, right? For this 2, what will be the ID? For this 2, the ID will be whatever we get from the left, that is left subtree's ID is 1, then 2, and then from the right what we get? From the right we are getting, since it's null, right, so we get 0 ID. So this 1 2 0, right? 1 2 0 comma will be there. We will be getting for this what will be the ID? So here ID will become the current size of the map, which is 1, like initially there is 1 right now, plus 1. So for this the ID will be 2, let's say. Okay, now when you go to this 4, let's say, so from 1 you go to this 4. When you come to this 4, again 0 0 will be the left, 0 will be from the left child ID, then 4 and then 0. So basically this will become the string. And so here I'm just taking, sorry, we are taking post order, right? So it will be 0 0 4, and we have already this here, right? We already have this here, so it means it's a duplicate, hence it's a duplicate, hence we will store its root, that is 4, in a, like, let's say vector. All right, so if it's a duplicate, that is count is 2, just push it into the this vector. Similarly for this 2, what will happen? From this 4, id returned will be this one, right? So 1 will be the id of the left, right child is nothing, so id will be 0, and 2 is itself value, so 102. Here I have taken in order by mistake, so 102. So this is a post order, so post order 102 is already there, hence we will be incrementing the, so guys see here, don't get confused, this is the id value, this is not the count, right? This is the id value. So we have already this pair, this triplet in the map, hence it's a duplicate subtree. So we will be returning, basically what we'll be doing, we'll be adding the root of this to here, right? So it's basically similar to the previous approach, just the case that here the subtree is identified by an integer, not by a string. So here time complexity in this case will become O of n. Why O of n? Because we are not doing unnecessary string, like if we are not storing the subtree in a form of a string, so there will be no n traversal. Like if let's say the worst case n nodes are there in this, serialized string, so there will not O of n traversal, that traversal is now eliminated and only O of n is there, time complexity. Okay, let's see the code once. So here see, we have we are making this triplet, and then after that we check if the count, if it's already present in the map. If it's not present in the map, we add it, and the id will be the size of the map plus 1. You can take it anything, id can be anything. Then you take the id, you increment the count of that id, so that you get to know that okay, if the id value has become 2, it means that we have encountered that tree for 2 times. So if the count is 2, add that root node in the res vector and return the id, because this traverse is returning id, right? So I hope you understood the problem and the approach. Try on yourself. Let me know in the comments if you have any doubt. If you found the video helpful, please like it, subscribe to my channel, and I'll see you in the next video. Bye.